Assalamualaikum warahmatullahi wabarakatuh to Dr. Jabbar Al-Fatah bin Yahya. My name is Muhammad Fairuz bin Muhammad Noor. I am from Group 6. So, in this video, our group will explain about group assignment project for power electronics. So, my group member is Muhammad Shamil, Pravin Raj, Jivan and Benjamin. So, I go to the introduction. In introduction, power electronics, a subfield of electrical engineering, use high voltage and currents to produce power for a variety of purpose. From common household electronic to aerospace equipment, a variety of application demonstrable consistent electrical power that address to the proper requirements. In this project, we use three-phase inverter for RL load. A three-phase bridge inverter is a device which converts DC power input into three-phase AC outputs. So, the DC to AC converter, also known as an inverter, and divided to category voltage source inverter and current source inverter.
My name is Muhammad Shamil Ilyas and my measure number is DE20127. Onto the following, I'm going to explain onto the design. For the design, which are essentially we are going to see more into the simulation type after the methodology part. I'm going to explain on what is the three-phase inverter. The three-phase inverter is used to change the DC voltage to three-phase AC supply. A three-phase inverter working principle is it includes three-phase inverter switches with single phase where each switch can be connected to load terminal. So as we can see for the figure below, the three-phase inverter is configured with 6 switches S1, S2, S3, S4, S5 and S6. For each of the 3 inverter switches, it is connected to the load terminal. This is a part of the 6 switches inverter topology. Going for the next part is the calculation. On this calculation part is on the input voltage, the 6 switch inverter topology. For the switching scheme, such as it is for the switching scheme, the line-to-line voltage and the harmonic distortion for both voltage and current. So this is part of the manual calculation which are compulsory for completing this assignment. That's all from me. Thank you.
In this part, I will continue the methodology. In this project, we use three-phase inverter for an RL loads. The type of inverter that we use are converting direct to DC to AC. And the power inverter is a crucial component in the distributed generator system, and it enables use to maintain the desired output voltage. And as DC to AC inverter is designed to detect the optimized full bridge and filter design to produce an accurate AC signal. And for the block diagram for DC to AC has been simulated using MATLAB simulation software.
Greetings to Doctor. My name is Pravin Raj and my entry number ID is CE 210 and 202. And also I'm from Group 6 as well. So today I want to explain about my part, that is simulation and result. So let's go. So this is the circuit we created for the three-phase inverter system. And for the three-phase, as we can see, for the three-phase we put the three sine wave here for the three-phase, and also a sawtooth generator to the phases. And also we add this block that got some block, and it will like add the inputs together, the sine wave and the sawtooth generator one. And also the another one compare to zero block. The use of the compare to zero block is to compare the signal, whether change the signal to 0 if false, or change to the input 1 equals 2 if it is true. And also the next one is not gate. The use of not is whether if it is 0 it will not send the input, and if not 0 and it will send the input, like that. It's a boolean gate like. And contrarily we use Goto. The use of Goto is to connect the supplies or connect the circuit without any wiring or like this floating icon. That is the use of Goto. And also we add the scope for the input one to make sure the line-to-line voltage is 415 volt. And for the circuit we use the IGBT/diode component to the circuit. We use 6 switches as a switches 6, and also we connected to the Goto. And also to reduce the noise and TSD for the inverter, we use the LC filter. The LC filter, the value of the L is we put 1500 millihenry, that is equals to 1.5 Henry. And also we use the capacitor, because I say LC filter, right? So capacitor we use 1 microfarad, the value of the capacitor. And then we use 3-phase voltage and current measurement to connect the scope. For the voltage scope this is, and this is one is the current scope. And also this is finally our load, and we put the load values as in the document, as in the PDF Dr. give 14 ohm for the resistor and 0.3 millihenry for the inductance, and we connect it to the ground, and that's all. So, and last we put the power grid and we choose the simulation type to the continuous. So let's run the circuit, and we put the stop time is 5 to simulate the circuit faster. So it's done. So I want to check the scope first. Let's zoom in a bit. As we can see, the voltage is 415 and for the up one is 0 to 1, and to make sure the line to line voltage is 415, we also check that one. So as we can see, the line to line voltage also for the three phases is 415, red, blue and yellow. And the next one, we go to the scope for the voltage one, and this is for the voltage one, voltage waveform, and we go to the current, and this is the waveform for the current, as we see. This one is voltage and this one is current. The current is approximately like 1.4 amp. And next one, we go to the main thing, that is THD, total harmonic distortion one. We go to the FFT. First one, we choose the input one, input scope. The signal dimension are same. The start time is 0 and the number of cycle I take per cycle, and we have to change the 60 Hz to 50 Hz because we use the 50 Hz, and the maximum frequency is 1000. And this one is frequency and variability, and the frequency as is Hz. And let's we compute the FFT. So the FFT for the input one is 0.11%. That is quite good one because we have to under the 7% as the project PDF says. And next one, we go to the scope data one. Same, we put the all parameters same and let's compute. And for the voltage one, we get 6.57 THD for 50 Hz fundamental. So this also is a good one and it's past the requirements. And lastly, we go to the current one. We compute the THD for the current scope, and here the current is 6.57. So it's also past the requirement because the requirement is the THD have to be under 7%. So we get 6.57%. For the results, that's only. And also another one I have to say, for the for THD to get under 7%, we add the LC filter. That is the use of the LC filter, because before we use the LC filter, we cannot get the THD that under 7%. So that's all from.
Selamat sejahtera and good day. My name is Jiwan Jaya Dayalan. My metric number is CE210092. On this project from our group number 5, I'll be presenting for the discussion part. So for our project, we have done for the SPWM 3-phase inverter for RL load. This type of inverter converts direct current to alternating current, which is DC to AC. And we have used MATLAB and proved the inverter diagram with the simulation. In the simulation for 3-phase input signals with FFT, we managed and able to get the total harmonic distortion, which is THD on 0.11%. About of that, for the 3-phase output voltage signal with FFT, the THD is 6.57%, which is less than 7%. Furthermore, the 3-phase current output signal with FFT also managed to get the THD around 6.57% and also less than 7. And we also have applied an LC filter to reduce the THD to achieve getting less than 7% as required. The LC filter parameters that applied, the inductor is 1.5 millihenry and the capacitance is 1 microfarad. The simulation result for voltage line to line voltage is 415, which is 415 volt 3-phase, and the inverter output waveform phase to phase current is 1.5 ampere and phase to phase voltage is 20 volt. The inverter output voltage pass through the output low pass LC filter which elements the higher harmonic frequency and generates the pure sinusoidal wave. That's all for me. Thank you.
My name is Benjamin Hoa Sian. My nomenclature is C210053. In conclusion, we're able to solve the problem and find a relationship between the knowledge learned in class for three-phase inverter system. The output filter is the main problem in this design because we got high percentage in the total harmonic distortion. For the result, show that the total harmonic distortion input waveform got a lower percentage compared to the output waveform. For our prediction, the three-phase inverter need an LC filter to reduce total harmonic distortion. That's all for us. Thank you.